Okay, we are working on T11 case problem 3 JSWorks, and just like I do every time I start one of these, I'm going to get my area set up here, and I'm going to click this button and open up my HTML page in a new tab so I can see it full screen. And I have a new, even larger screen today. I've got a new screen, so this hopefully should look even better. And then I'm going to squeeze this over anyway so I can really maximize the room that I have to code. And then I'm always going to read my summary so that I know what it is that I'm working on. Got to treat these like they're real people and real clients and kind of know what they want so that I know what I'm working on. So let's get started with this. JSWorks. George or Jorge Soto is the owner and administrator of JSWorks, a website containing JavaScript tutorials, tips, and specialized apps. We could use some JavaScript tutorials and tips. Jorge is working on a multi-page tutorial concerning the creation and use of document nodes. You are helping Jorge maintain his website and have volunteered to work on a page I didn't volunteer. I volunteered to work on a page describing the appearance of the document node tree. Jorge would like you to include a node tree that is based on the article he is writing so that visitors to his site can see the complete appearance of the node tree for a sample HTML fragment. Figure 12-56 shows a preview of the page, so this is what it's going to look like when it's completed. I have the solution actually. I'm going to open the full HTML version. Case 3. Oop, I opened in a different browser. There we are. Okay, so here is the completed assignment. Here's the picture of it. We're just concerned with this area right here. And this is what we have at the moment. We don't have that area yet. Oh, we're going to need to use recursion to navigate through the entire structure of Jorge's article. Recursion is when you have a function that calls itself, and every time it calls itself, in our case JavaScript, the browser that's running JavaScript, every time that function calls itself, it's going to freeze the outside function. Okay, the function is going to call itself, so there's going to be like some parent-child relationship between the function that's running and another execution of that same function. I'm assuming that every time it gets called, it's going to pass parameters to itself as well. And then it's going to exist in a new set of memory so that we have two instances of the same function running. They will have their own set of memory, their own set of variables in memory that could be different values. And then that child function may call itself again, and we could have another layer of recursion. I don't know how many layers we'll have, but that's what recursion is. There's a funny description of recursion because recursion is a function that calls itself. So in some places that you go online and you look up recursion, they say to understand recursion, you must first understand recursion. And it's just calling itself. It's funny. It's funny once you understand recursion, that is. So carrying on with my terrible joke here, as it proceeds through the article, it will record each element node and text node, displaying them in a nested list alongside the article text, just like we have here we'll be gathering all the nodes and displaying them in this list. So these are, I assume these are the same nodes of, let me zoom all the way up to the top, of the actual article to the left. We have some text, working with nodes, text, understanding the node tree, text, JavaScript organizes. Yeah, this is the node tree of the actual content here on the left. That's what we're going to build. So let's go on and actually get started a little bit. Use the editor to put your name and date. It's December now. All right, I don't have to do both files. I don't. You might. Go to the node HTML in your editor. Within the document head, create a link to the CSS style sheet and the JavaScript file and another JavaScript file. Oh no, and just the one JavaScript file, but I'm going to load it asynchronously. Okay, so I'm going to link, well, I like to copy and paste. So I'm going to link the jstree.css. All right, so I copied and pasted that, copied and pasted the file name over it. And now I'm going to do a script. The script has a source. This one is going to be asynchronously loaded. Asynchronously loaded means that it's going to download the file and asynchronously keep processing the HTML. Once the file has been downloaded, though, it will pause the HTML parsing and parse the script instead. So it's going to save time and speed on the user's point of view, but we will still be forced to wait before we can run JavaScript against the page, because some of the page may not have been created by the time our JavaScript runs. So I have this, and I should be able to get this check mark. That's going to be the easiest step we do today. All right, next page. Return to the JavaScript file. I think I can close this CSS file. Go to the JavaScript file. Jorge wants you to keep track of the total count of nodes, element nodes, text nodes, and whitespace nodes. Below the comment section, create the following global variables. Okay, a variable for node count, element count, text count, and whitespace count. Set their initial values to 0. We're going to count all of these. All right, we're going to make these variables var keyword, and we want it to be called node count, default value or initial value of 0. Next one is var count equals 0. Oops. Yeah. Text count equals 0. And WS count or whitespace count equals 0. Global variables. Alright, and that should be easy enough. It was actually easier than that previous step. I guess that wasn't the easiest step. Create an event handler that runs the make tree function when the page loads. an event handler that makes the makeTree function run when the page loads. So when the page loads, that event is window.onload. And if I set that equal to the makeTree function with no parentheses, no arguments, it will run that function when the window loads. Not every type of element has an onload event. The window does. And I don't want to use these parentheses. If I put those there, what's going to happen is this function is going to get called immediately. And if it returns a value, the return value will get set to the onload event. I don't want the return value. I want the function itself to be set to the onload event. So there's that. Am I going to get a check mark for that as well? Well, these steps are getting easy. The next one's probably going to be really hard. Let's see. The makeTree function will be used to create a node tree for the source article on the page. Create the makeTree function, adding the commands described below. Within the makeTree function, create the following aside element fragment. So within the makeTree function, I'm going to add a few more line breaks here so that I can code closer to the top of the screen. Move this over. And let's see. Within the makeTree function, create the following aside element fragment and append it to the section element with the ID main. It doesn't tell me. Usually they're going to tell me like what to name all my variables. And they're not going to tell me that this time. Okay. Cool. All right. Create an aside fragment. Create an aside fragment. And then assign that fragment to the main element. So the aside fragment, we're going to do, we want to do this as a node. So var aside fragment equals document dot create element, and the type of element we're going to create is an aside, and we pass this as a string argument to the create element method. All right, and this aside element has an ID and it has an h1 tag inside of it. So we could do this any number of ways, but I'm going to say aside fragment dot ID equals, what's it called? Treelocks. And then I could make more elements and add them to this element, but I'm just going to do the old inner HTML that we've been using. So aside fragment dot inner HTML equals, and that inner HTML is going to be all the inner HTML there. And h1 with the text node tree. Right, so that's the aside element, and then I'm going to append that to the main element. Main element, all right, they've not told me what to name these variables at the moment. Usually they do, but I'm having fun naming them myself today. All right, document.get element by ID. Right, so we're going to look for the element with the ID of main. It's going to be in here somewhere, right? ID of main. So it's there. So I have that. I don't know if I'm going to use this later on. That's why I created the variable. Main element without the typo, I prefer. Dot, right? They want us to append it. Append child. And the child we're going to append is this fragment, a side fragment that we just made. So if we do that, that'll take us to there. If I run my page, aha, see, now I have some code in here already. I have just an aside fragment, an aside with an H1 in it. Very nice. See, it's working already. Node tree will be created within an ordered list. Declare a variable named node list. Now they're telling me what to name it. Containing an initial OL element node that will be the foundation of the node tree and append to it the aside fragment. Wait a minute. And append, oh, sorry, append it to the aside element. I got it. I read it backwards. All right, so I have my node list. This is going to be equal to a new OL node. So document dot create elements, just like I've done. Create element, and the element I want to create is an OL. I pass the string OL. I have an ordered list element, and now I'm going to append that to the previous one and make the aside fragment. So aside fragment, fix my typo here, dot appendChild. I'm using the IntelliSense here a little bit. AppendChild, and the child I want to append is node list. So I'm going to put that unordered list into the aside fragment. There's nothing in the unordered list. If I were to run this, I probably wouldn't see any changes. I don't, just because there's an empty unordered list in there. If I inspect this, I have my aside. I don't even have an unordered list right now. Huh. Console. Oh, I'd have an error. I have a typo. Document is undefined. You are right. It is supposed to be document. There we go. Now I have this unordered. Oh, I do have something to see now. How about that? This is the unordered list. Right? They've styled it with a bunch of CSS. Right? While we're working on JavaScript, I really want to have my console open to show me any errors. Okay, so the node tree will be created inside the unordered list or the ordered list. We have that. We've added it to our aside fragment, our aside element fragment. Next, the node tree will be based on the contents of the elements matching the CSS selector main article. And that, I assume, is what's on the left over here, right? Because we're going to build it to match that. Declare a variable named source article. Can do. Source article that points to these elements. Use query selector method. Why would I want to do that? Let's have a look. Main article. Ah, looks like there's a typo. All right, so I have a main, and inside of it, I have an article. There's no space in between this. It just says main article, but it should be main and article. That's why I'm confused here. All right. Then that's why they say CSS selector main article. They don't have their space in the right place here. It looks like they actually put maybe a space in the front. All right, can do that. So source article is going to be equal to query selector main article. Document, and I typoed the same typo again. Document dot query selector, and that query is going to be main space article. Source article is going to point to these elements, right? Because query selector article, there we go, article. Query selector is going to return the first element that matches this. So if there's more than one, I'm only going to get the first one anyway. The contents of the node tree and the count of the different global variables will be updated using a function named makeBranches, which you will create shortly. I can see it's right down here. Call the makeBranches function using the source article and node list variables as parameter values. All right, so just call in a function, makeBranches. All right, and I'm going to use the source article as parameter 1 and node list as parameter 2. Let's see if that's everything that's in there. I actually have one more thing in here in this function in my answer key. So we just called that function. You don't have to worry about what it does yet. Now we're going to worry about what the make branches function does. And then we're going to add something to the make tree function. All right, so here comes the hard part. Let's refresh our page to see what it looks like so far. All right, not any different has changed yet. We've just referenced a few things and we're calling this function. This function make branches doesn't do anything yet. The make branches function, this is what's going to be used to crawl through. We're passing it our source article, which is the source article where we're getting all the content from, and we're passing it the node list, which right now is just that unordered list where we're going to put everything. So we passed it the article we're going to get all the information, and we passed it the place where we're going to put all the information. That's what we've done with the make branches. And now we're going to build it, power it, and see what it does. It's going to call itself repeatedly. So it's going to call itself, the first argument is going to be what you grab, and the second argument is going to be where you put it. And then it's going to crawl on down the list of things and grab something and put it in something. Grab something and put it in something. And we're going to do that repeatedly. The function will have two parameters named tree node and nested list. It's already created. The tree node parameter stores the current node from the source article, and the nested list parameter stores the structure of the node tree deployed in the web page. Add the commands described in the step below. Each time make branches function is called, it's because a new node has been discovered in the source article. Increase the value of the node count by 1. So the first thing we're going to do is increment the node count. And that's that global variable node count. Node count plus plus. That's going to increment it by 1. So there's one node every time it gets called. Create the following list item HTML fragment, storing the list item element in the li_lm variable and the span element node in the span lm variable. So we're going to create two node elements to match this right here, because if we look at I've got the answer key here, we're going to make everything look like it's got some lines and node trees and stuff. Then we need to create that. Make some space here. All right, so I need to create the li element, list item element. It is going to be set to an li. And document.createElement, li, list item element. And I just want to put that HTML inside of it equals this right here, this plus dash dash. And then I'm going to make the span. It's called span lm equals document.createElement. And it's going to be a span element. So I will pass the string argument span. And the span has nothing in it. So I'm just going to put the span inside the list item, and span element in the list item, put the list item into the nested list. And the nested list would be the argument that gets passed is the container. So every time this gets called, the first thing we do is we put a list item and a span inside of it, because every item in this output has to have this structure wrapped around it. Okay, so li list item is going to get the span append child. The span element gets put into the list element, and then the list element gets put into the nested list. So far in this function, we've increased the node count, because we know every time this function gets called, it's because there's a new node we're building. And I've created a list item, put some text and a span inside of it. Well, put some text in it, created the span, and then I put the span in it, and then I put all that into the nested list, which is the container that we're putting everything into. Moving along, if tree node, that's the first one, that's the source article when it gets passed anyway. If the tree node represents an element node, then do the following. Else, if tree node represents a text node, then do this, and then carry on. So let's do that. So if tree node equals an element node, else if tree node equals a text node, we're going to do something over here. So how do we know if tree node equals a element node? Tree node, that's the variable that gets passed to us. How do we know if tree node equals an element node? If tree node dot node type equals 1, 1 is element nodes, okay, and my answer key is using the triple equals. I think we can get away with the double equals. Let's try it and find out. All right, what are we going to do if the tree node equals an element node? You know what? Let's write the next one as well before we forget. Else, if tree node dot node type equals 3, that's a text node. 1 is element node, 3 is a text node, and 9 is the document itself. And I don't remember what the other numbers are, but I could look it up. All right, so if the tree node is an element node, increase the element count. Remember, we have our global things that we're counting. Elm count plus plus. We're going to increase that by 1. Right, so node count went up by 1, and if that node was an element count went up by 1. So at the end, our global variables here, the element count, the text count, and I guess the white space count, all those combined will probably equal the node count. So increase the element count, add the class attribute to the span element node, setting its value to element node. So the span element node, which we created as a node, we appended it to the list item, but because we assigned it to a variable, we still have access to it. Okay, so we're going to add a class element to that. So its value is, or its variable is span element, and we can set attribute. All right, and the setAttribute method, we give it attribute name and an attribute value. Those are the two arguments. So the name of the attribute we want to set is class, and the value we want to set is element node. All right. And let's see. Append the text string element to the span element node where element is the name of the HTML element. Use the text content property to append the text to the element tag and not the element tag itself. All right, so append the text string to the element node, span element dot text content. All right, text content, we've used that before. It's similar to inner HTML. All right, span element text content. We're going to set that to this string, but the string is going to be element, and it's going to say what it is. So if we look at the picture here, each one of these has this string of what it is, and it tells us the actual element node name of that element. So text content equals, we're going to build a string. Okay, and value or element, that's what they want it, right? It's actually going to be equal to the name of the HTML element that we're working with. And we're working with tree node. Okay, remember tree node, if the node type is an element, this is what we're doing. So tree node is the element we're working with, and we get this value from node name. The node name will be whatever the name of that node is, whatever the HTML element name is. So if it's an H1, it'll be H1. If it's a P tag, it'll be a P. If it's a div, it'll be a div, and so on. We'll get that right from that, and we're going to put the greater than and less than symbols around it so that it looks like an element, and we're going to stick that in the text content of our span element. And we do all that if it's an element node, so if its type was 1. Right, that is that section, actually. I don't think we don't get a check mark until the very end, so let's keep working. Next, if the tree node was a text node, and we wrote the if statement already, so let's see what we're going to do in here. Increase the value of the text count variable, of course. Our global variable is counting all the node types. If it's a text node, we're going to increase the text count by 1, plus increment. Okay. And declare a variable text string equal to the value of the text node. So if the node type is a text node, type 3, we're going to make a variable equal to that value. So var text string. If MindTap gives me a name of a variable to use, I'm going to use it because when they test me, they may check that actual name. Earlier, they didn't give me a name of a variable to use, so I made my own up, just made it up. And so far, so good. Right, so this one is called text string. It's going to be equal to the value of the text node. So nodes they all have a value. If it's an element node, that value is going to be null. And that's because elements don't have content directly in them. If it's a text node, those text nodes, they don't have other children, they hold the content. So nodes either are going to have children, other nodes, or they're going to have content, not both. It's a sad life, but that's what they do. All right, so the text string is going to be equal to, we're still working with tree node, remember, tree node.nodeType3 is a text node, so tree node dot node value is going to be equal to that text value of that text node. Okay, number 3, Jorge has provided a function named isWhitespaceNode to determine whether a text node represents whitespace or not. Call the isWhitespaceNode function using text string as the parameter value. If the function returns the value true, then do the following. That means that we need another if statement, and if that returns false, then do something else. So we're going to call isWhitespaceNode We're going to call it right in this if statement because this function returns true or false, and if tests true or false. So we're going to put that right in there, and we're going to pass it the text string as its argument. All right? And this way we only have to run the function once each time, and whatever the value gets returned, then we'll do either true or false, whatever it is. So if it was true, increase the white space count by 1, because now we're counting the white space. WOS count plus plus. Change the class attribute of the span element node to white space node. So we're still in the same function. We created span element earlier. We still have the ability to change, to access it and change its class. So I'm actually going to copy and paste this this line that we did earlier. I'm going to set the class now to, instead of element node, it's going to be called white space node, and append the text string text to the span element node. So just like we did before, we're going to append the text string. This time we're not using a value or a node name. We're just going to do hashtag text because that's actually what the name is of all the text nodes. We don't have to access the node name this time because all text nodes are named text. All right, and that is that part of the if statement. The next part of the if statement is if it was not a white space, we change the class of it to text node, and we append the text string text where the text is the value. Okay. And that, all right, I got it. So it was a little weird, that last part right there. But if it's not white space, we're going to give it the class name of text node. That part was easy. And then number 2 here, we're going to append the text string text to the span element node where text is equal to the value of the text string variable. So that means that I'm just going to say text string. You say span dot text content equals text string. But they gave us an extra step for no reason there. Right, I'm going to clean up my spacing a little. And I've finished that part anyway. I got more of this function. Okay, and my coloring and my highlighting working. If element node type. All right. Next, the make branches function should recursively, that is, it's going to call itself, move through the different levels of nodes in the source article to apply recursion. Right? The way you have to apply recursion the right way. If you don't, you'll just create an infinite chain of functions calling itself. And then you fill up all your computer's memory and crash everything. We don't want to do that. To apply recursion, test whether the number of child nodes of the tree node is greater than 0. If it is, then do the following. Okay, let's create the test first. Okay. If the number of child nodes of the tree node element is greater than 0, so tree node dot child nodes dot length is greater than 0. Okay. If that's true, then do the following. Create the following HTML fragment as an element node with the name new list. Right? We're making another OL. This one's going to have a pipe inside of it. Append the new list to the nested list. Nested list is the container that we're working with still. We have not done too much of that yet. We put that span in that list item in there. But if there's children, we're going to make a little pipe. As we see right here, we see these little vertical lines. Every time there's a child element, a child node, we have that vertical line and points to the child node. That's what we're going to make. Loop through the child node's tree node using n to represent each child node, and a for each child node to call the make branches function using n and new list as the parameter values. Okay, so if you remember when we first created that box over there, we made a node called an OL, right? The node list, and we pass that to the make branches. The very first time make branches gets called, we pass that OL. And then every time we have child ones, we're going to create another OL with this line going down. And then we're going to loop through all the children, and we're going to call make branches again for each of the children. And that way, if there's a series of children, it will just call them all in series. It will call one. If that one has children, we'll just have a lot of recursive functions stored up in memory until they finally end, and then it's very cool how the recursion works. But I'll try to talk you through as I write it. Okay, so if I have children, if the node has children, I know I have children. If the child node's length is greater than 0, create a node called new list. Okay, that one is going to be an OL element, just like we did the very first time. Every succession is going to be wrapped around another ordered list. Okay, and then as soon as you get inside of it, we put list items inside the ordered list. All right, see how that works? Okay, I need to add a pipe character to this. Pipe character is a vertical line. You press shift and it's the key above enter where the backspace is. That's the pipe character. Right, I'm going to put that into the OL. Okay. The parent OL around everything doesn't have that. But each time this list creates a new inner space section there, new child knows we have that OL. Okay. And then append the new list to the nested list. The nested list is, of course, the one that we're currently working on for this make branches function. So nested list dot appendChild, and we're appending the new list that we made. So if there's children, we're going to put another OL inside the current thing that we're working on, and then we're going to loop through all those children so that we can process each one of those children. Okay. It's a for loop. And the way we're going to do this for loop is because we're looping through a bunch of children or child nodes. Right, we're going to use using n, just like they say. Okay, we're going to do var n equals. We're still working with, every time this function goes, it's working with tree node. It's working with its own instance of tree node and its own instance of nested list. And when the function calls itself again, it gets down here, we're going to pass a new value to it inside of the node list, of the parent-child relationship with all the nodes. We're going to get down to some child, and we're going to pass it those references as the new tree node and nested list for it. And then it's going to keep processing. Okay, so we're going to start our loop as tree node dot first child, and then we want to stop looping when n is equal to null. And we want to use this full not equal equal when n is not equal to null, because element nodes, their node value is equal to null all the time. So if we just did a regular n not equals null, what would happen is all the element nodes would be equal to null, and the loop would end prematurely. All right. And then each iteration, we're going to say n is going to now be equal to n dot next sibling. Each time the loop goes through, we're going to set n equal to its next sibling. So what happens is when what's this called? Make branches, the first time this gets called, we pass tree node, okay, and that's equal to the source article. This whole article on the left-hand side, that's going to be tree node the first time. And on the right-hand side, this empty node tree, okay, this OL, that's going to be on the right hand side, that's going to be nested list. So tree node on the left, nested list on the right. We're going to process just like we did. We're going to create this little plus sign with a dash dash and add that to the right hand side. And then if it's an element node, we're going to add the element name. If it's a text node, we're going to test whether it's white space or not. And then we're going to see if there's child nodes. And if there is child nodes, we're going to add another OL on the right hand side. And then inside that OL, we're going to loop through all the child nodes on the left, the direct child nodes of the one we just picked. So initially, we picked the master around the whole thing. And of course it has children. We can see that it has all that stuff on there. So then we're going to go into each one of its children, loop through, and for each one, we're going to call the make branches function again, and we're going to pass it that child that we're currently looking at on the left. So not the master anymore, but the child, each child is going to get called on the left. And then each of the new list, the new OL that we created, is going to get passed on the right hand side, and it's going to circulate through all the children on the left hand side. It's going to go through all of them and run this function one more time, test whether it's an element node or a text node, and start adding things on the right hand side. It's going to, on the right hand side, it's going to add them into the new OLs that we keep creating. So every time there's a child on the left hand side, we create a new OL on the right hand side, put it in there, find more children, and do the process over again until we finally run out of all the children to look at. And then all these functions are going to start finally ending, and memory will finally get freed up, because every time this function calls itself, that first function call is going to recurse and loop all the way through everything on the document, and the first function call that opens will actually be the last one that closes, because it's going to remain open until everything else finishes. It has to, because when we get into the loop and we call another function, we're still in this main loop the whole time. And so in this loop, we're going to call the make typo. We're going to call the same function, make branches, and we're going to pass it n, that's the child, for the tree node, the left hand side, and on the right hand side we're going to pass it new list. And it's all right to pass it new list, because remember, we just appended new list into the right hand side. So we put new list into the right hand side, and we found the next child on the left hand side, and we start the cycle over again until eventually we run out of stuff on the left hand side, and we put it all in the right hand side. All right, so we did that. That is going to be a check mark. Hope I don't have any typos. Hope I get it. Think I'm going to get it? I almost did more talking than coding this time. Oh, I did not get it. I got 2 out of 6. Let's see. It's probably typos. Node count. Node count variable incremented. Node count incremented in make branches. Well, it definitely is. However, under use strict, hey, my thing works already. But yeah, I don't think node count is working right. I'm going to turn off use strict. Let's see if MindTap hollers at me too much. See if that helps me. Because those global variables, no difference. These global variables, oh, wait a minute, expected 238, but actually equal to 239. So it's working, it just doesn't have the right count. It's off by 1. Hmm. You know what? It's off by 1. Let me just fake it. Because I think maybe they changed the solution, but they forgot to change the count on their end. I don't see anything wrong on my end. All right. No. Expected 237. Well, I'm still. Nah. Not very cool. I subtracted 1, and it's still. Let me try node count. Let me just try plus plus node count instead of node count plus plus. What that does is it adds 1 before you measure it, just in case they are doing some sort of breakpoint trickery. Probably not going to work, but I want to try it. No difference. And put it back the normal way. Expected 238 to equal 239. All right, I'm going to come back to this one and see what the other issues are. white space count. This other one's a count. All right, maybe it's this last one. Yeah, my count is going to be off again now. Let me do these triple equals here. If you remember when I put those in, I thought I would get away with it, but maybe I can't, and that's why my counts are getting thrown off. No change. All right, well, I found it. Somewhere in my HTML code right here, I had one missing character. I don't know why. I don't know if I did it on accident or what it was, but I had one missing character on line 120. And of course, it was an element tag character that messed up the count of my nodes. And so if I put that back in there and I rerun it, nothing else has changed. I'm going to get the right counts. That's terrible. I'm going to have to do this over again from scratch and see if it's actually like that and report it. All right, so one thing I actually did, I did the next step. I'm going to delete it and redo it. All right, the next step, return to the make tree function. All right, the first function, it's like the setup function. Add commands to display the total count of nodes, element nodes, text nodes, and whitespace nodes within the span element whose IDs are total nodes, element nodes, text nodes, and whitespace nodes, respectively. I'm going to cheat a moment because I don't like to type and make typos. So I'm going to copy and paste this in here. And all right, so document.getElement by ID, total nodes, another one ID element nodes, another text nodes, and WS nodes. And I set their text content equal to node count goes with total nodes, element count goes with element nodes, text count with text nodes, and whitespace count with whitespace nodes. And what this does is those things exist in various places in this upper area right here. And their spans, they have their colors set to blue, and the numbers pop in there after the page loads and after everything is counted. So at first, it's not there, and then the page loads and gets counted. And so those are the counts. All right, so I can come back in here and get checked off for that. It's a simple task, but they didn't want you to do it until the end because I don't know why they didn't want you to do it until the end. Probably because it's not going to happen until after the make branches gets called anyway. All right, then I can go to the last step, which is verify. We don't do the verify uh, because I've been verifying throughout the whole process by clicking on my page and looking into it. Okay, we can see all of our tags and all of our little text and our pipe character and everything. It looks pretty good. Okay. Um, I'm not going to validate. I never do because the W3C HTML validator is out of date and it would not give me accurate information if I tried it. And I've always been building it all the way through. So that is this assignment. All right, when you get to yours, remember to have a double check around line 20 of your HTML and see if you're missing that character in there like I was. I don't know if I did it on accident or if it was already like that.